A discovery was made deep beneath Yellowstone National Park. A discovery that, according to the headlines, threatened to rewrite the future of a continent. In late 2022, news outlets across the globe ran a story that felt seismic. The magma chamber, the enormous engine of rock and heat that powers Yellowstone, was bigger than we thought. More liquid, more active, and according to the most alarming reports, it was expanding. The unspoken implication was clear. The clock was ticking faster. The supervolcano was waking up. A cataclysm 631,000 years in the making was supposedly stirring from its slumber. But what did the data actually say? And what did the scientists who found it really believe? The answers are far more complex and far more unsettling than any headline. So what is the very first thing you think of when you hear the word Yellowstone? A geyser? A supervolcano? A national park? Let me know in the comments below. It helps to know what brought you here. A lot of people watch these documentaries and they forget one crucial single step. If you value this kind of deep dive analysis, the kind that goes beyond the clickbait, do one thing for us right now. Hit that subscribe button. It is the only way to make sure that you do not miss the next part of the story. Don't let an algorithm decide what you see. Take control. Okay, let's begin. Yellowstone exists as a permanent source of global anxiety for a very specific reason. History written in layers of ancient ash spread across half of North America. 2.1 million years ago, a force of unimaginable power tore through the Earth's crust in what is now Idaho and Wyoming. That was the Huckleberry Ridge eruption, the first and largest of Yellowstone's three great caldera-forming events. It was an eruption so vast it defies modern comparison. More than 2,450 cubic kilometers of rock and ash were ejected, enough material to bury the entire state of Texas under nearly 13 feet of debris. The ash from that single event has been found as far away as Louisiana and California. It was a planetary event, one that altered the climate and shaped the geology of a continent for millennia. Then, 1.3 million years ago, it happened again. The Mesa Falls eruption. Smaller, but still a colossal event that formed a new, smaller caldera. And then, 631,000 years ago, came the eruption that created the world we now watch so nervously. The Lava Creek eruption. This event formed the modern Yellowstone caldera, a 43 by 28 mile depression that stands as a permanent geological scar. It ejected over 1,000 cubic kilometers of material, blanketing the Midwest in ash and ushering in a volcanic winter. These are not just historical footnotes. They are the precedents. They are the evidence that proves what the ground beneath Yellowstone is capable of. This immense power is fueled by a two-part subterranean engine. Deep beneath the surface, from 20 to 45 kilometers down, lies a vast reservoir of basalt magma, fed by a stationary mantle plume, a hot spot in the Earth's mantle that the North American tectonic plate is slowly drifting over. This deep reservoir heats the crust above it, melting the rock to create a second, shallower magma chamber. This is the one that worries everyone. A chamber of high silica rhyolite magma, sitting just 3 to 8 kilometers beneath the tourists and geysers of Yellowstone National Park. For decades, scientists tried to understand this shallow chamber using the best tools they had, a technique called seismic tomography. It works on a simple principle. Seismic waves from earthquakes travel more slowly through liquid than they do through solid rock. By measuring the speed of these waves as they pass through the crust, scientists can create a kind of CT scan of the Earth, mapping out areas that are solid and areas that are liquid. And for decades, the picture that came back was blurry. The models showed a large area of slowed seismic waves, but the resolution was poor. The scientific consensus settled on an estimate. The shallow magma chamber contained between 5 and 15% liquid magma. The rest was a solid, crystalline rock. It was not a lake of fire. It was more like a sponge, a solid matrix with liquid magma filling the pore spaces. Scientists called it a crystal mush. This crystal mush idea is key to understanding the entire system. Have you heard this term before, or is this the first time you're seeing it broken down this way? Tell me below. I read all the comments. This mushy, mostly solid state was reassuring. It suggested a system that was largely dormant, stable, and incapable of producing a massive eruption. The volcano was sleeping, buried under miles of solid rock and scientific certainty. The models were consistent. The numbers were stable, and the world a few miles above went on, largely unaware of the blurry picture that scientists were working with. A picture that was about to be brought into shocking, crystal clear focus. The problem was the blur. For geophysicists studying Yellowstone, the 5 to 15% figure was always an imperfect estimate, a best guess based on fuzzy data. You cannot drill into a magma chamber. The heat and pressure would vaporize any equipment man has ever built. You can only look at it indirectly, through the echoes of seismic waves. And the traditional method, waiting for earthquakes to happen and measuring the waves, was like trying to take a photograph in a dark room, using only the occasional flash of a distant lightning strike. You get an image, but it lacks detail. It lacks precision. A team of scientists decided that was not good enough. They included Dr. Ross McGuire, then a postdoctoral researcher, and now an assistant professor at the University of Illinois Urbana-Champaign, and Dr. Brandon Schmont at the University of New Mexico. And their work was built upon a foundation laid by Dr. Min Chen, a brilliant seismologist at Michigan State University. They wanted to replace the lightning strike with a constant source of light. They wanted to see the volcano not just when the earth shook, but at all times. The plan was audacious. The execution was computationally immense. If you find this level of scientific detail fascinating, do me a quick favor and hit that like button. It tells the algorithm that this kind of in-depth storytelling matters. And if you know someone who loves science or geology, share this video with them. It helps more than you could possibly know. Instead of waiting for earthquakes, the team turned to a technique called full waveform inversion of ambient noise correlations. It is a term that sounds impossibly complex, but the idea behind it is revolutionary and surprisingly elegant. The Earth is never truly silent. It hums. This planetary background noise comes from the constant rhythmic crashing of ocean waves against every coastline on the planet. This energy does not just stop at the shore. It travels through the continental crust as faint, continuous seismic vibrations. For decades, this ambient noise was something seismologists tried to filter out of their data. It was interference, static that obscured the clean signals from earthquakes. But Dr. McGuire's team, using methods pioneered by a new generation of computational seismologists like Dr. Min Chen, saw it differently. What if that noise was not noise at all? What if it was the signal? What if you could use supercomputers to listen to this constant planetary hum, correlating the signals from hundreds of seismometers, and use it to build a picture of the Earth below? It would be like flooding the dark room with continuous light, revealing everything in perfect detail. In 2020, the University of Utah seismograph stations deployed an unprecedented array. 650 portable seismometers were placed across the Yellowstone region, a dense network of electronic ears listening intently to the ground. For years, they recorded every faint tremor, every distant ocean wave vibrating through the rock. This mountain of data was then fed into supercomputers. The task of those computers was monumental. They had to take the chaotic hum recorded by hundreds of instruments and, through a process of intense mathematical correlation, transform it into a coherent, three-dimensional map of seismic wave speeds. It was like taking the sound of an entire stadium, full of people talking and isolating a single conversation. The algorithms for this task were the key. They had been developed and refined over years, and the work of Dr. Min Chen was particularly vital. She was a world expert in this exact field, a master of the computational methods needed to unblur the data, to make the Earth give up its secrets. Tragically, Dr. Chen passed away unexpectedly in 2021, before the final study was published. Her colleagues made it clear that her contribution was not just important, it was indispensable. The final paper was a part of her legacy. The supercomputers ran for months, crunching the numbers, running the correlations, threading a computational needle through a mountain of planetary noise. Slowly, an image began to emerge. A picture of the Yellowstone Magma chamber, clearer than any that had ever been seen before. And the numbers it was showing were different. They were higher. Before they could publish, the team had to be certain. They were not just updating a number, they were recalibrating our entire understanding of the planet's most famous supervolcano. They checked and rechecked the data, the models, the inversions. The result was undeniable. The old picture was wrong. Not because the scientists were mistaken, but because their tools had been imperfect. The foggy lens had been replaced with a high-definition sensor, and on December 1st, 2022, they showed the world what they had found. The report, published in the prestigious journal Science, was titled Magma Accumulation at Depths of Prior Rhyolite Storage Beneath Yellowstone Caldera. The language was academic, measured, and precise. The number it contained, however, was anything but. The analysis revealed that the partial melt fraction in the shallow rhyolite magma reservoir was not 5 to 15%. It was 16 to 20%. To the public, the number was a shock. It was an increase. A significant one. The percentage of liquid rock, the very fuel for a supereruption, had seemingly jumped overnight. Media outlets seized on the most dramatic interpretation possible. The magma chamber was more full of magma than previously thought. It was expanding. It was growing. Panic, the internet's most renewable resource, bloomed. The image was terrifying. A volcano that scientists had assured us was mostly solid was suddenly becoming more liquid, filling up like a tank of gasoline. But that is not what the science said. The scientists behind the study found themselves in a new and uncomfortable position. They were no longer just geophysicists. They were crisis communication managers. Doctor, Ross McGuire was direct. We didn't see an increase in the amount of magma, he stated. We just saw a clearer picture of what was already there. Dr. Brandon Schmant, his co-author, put it even more plainly, trying to dismantle the lake of fire myth once and for all. It's not all melt or one big blob of liquid in that volume, he explained. It's more like a lot of us solid crystals that are pretty hot, and about 20% melt exists in the pore spaces between those solid crystals. This is where the geological snow cone analogy becomes so vital. Imagine a snow cone. The vast majority of its volume is made up of solid ice crystals, packed together. The sugary syrup fills the tiny gaps, the pore spaces between the ice. The Yellowstone Magma chamber is that snow cone. The rock crystals are the ice, and the 16 to 20% liquid magma is the syrup. You cannot drink a snow cone through a straw, because it is mostly solid. It is immobile. The most important voice in calming the public fear was that of Dr. Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory for the Huskies. He is the man responsible for the official monthly updates on the volcano's status. His analogy cut through the noise. It's like getting a better lens for your camera, he said. Things are coming into more focus. The chamber had not expanded. Our ability to see it had. But then came the most critical piece of information. The number that puts the 20% figure into its proper and startlingly undramatic context. For a volcano of this type to actually mobilize for a caldera forming supereruption, the magma chamber cannot be a slushy, crystal-rich mush. It needs to become a mobile, crystal-poor liquid. The crystals must melt. The entire system needs to be energized, and scientists have a number for that. A threshold. It is called the critical melt fraction. That number is 35 to 50%. Let that sink in. For Yellowstone to even begin to have the potential for a supereruption, the amount of liquid magma would need to roughly double. At 16 to 20%, the magma chamber is not on the verge of erupting. It is physically incapable of it. It remains a largely solid, rigid geologic structure, a mostly frozen snow cone. The shocking reversal in the story was this. The new, higher, scarier sounding number actually made scientists less worried about an imminent eruption, not more. Doctor, Poland even said it directly. We're even less worried about an eruption now, and I wasn't worried before. Why? Because the new, high-definition picture confirmed with greater certainty than ever before that the system was in a stable, dormant, and non-eruptible state. The blurriness of the old data always left room for doubt. Maybe there was a hidden pocket of more liquid magma the models couldn't see. But the new, clearer image revealed the entire system, and it was all solid. Reassuringly solid. The discovery wasn't that the volcano was more dangerous. The discovery was that our old cameras were terrible. The monster we thought we were looking at was, in fact, sleeping far more soundly than we ever knew for sure. I know, I'm asking again, but look at the data. The vast majority of people watching this deep into the video still haven't subscribed. If you have made it this far, you are clearly invested in this story. That red button below isn't just a button. For us, it's our lifeblood. It's a signal that this work matters. It takes one click for you, but it changes everything for us. Thank you. The science was clear. The magma was stable. The experts were not worried. And then, on July 23rd, 2024, Yellowstone exploded. Or so it seemed. The location was Biscuit Basin, a popular thermal area just over 2 miles northwest of Old Faithful, known for its geysers and colorful hot springs. It was approximately 10:00 am Mountain Time. The area was filled with tourists, walking the boardwalks that snake between the steaming pools. One of those pools, a hot spring known as Black Diamond Pool, had been quiet for years. Suddenly, it was not. Without warning, a violent explosion tore through the placid surface. A massive column of boiling water, mud, steam, and rocks erupted from the pool, shooting 400 to 600 feet into the air. The blast was powerful enough to hurl grapefruit-sized rocks across the area, destroying a section of the boardwalk and sending terrified visitors running for their lives. Miraculously, no one was injured. Within minutes, cell phone videos of the explosion were online. The footage was dramatic. A violent black plume erupting from the ground in the heart of Yellowstone. To a public already primed by decades of disaster movies and years of online fearmongering, the conclusion was obvious. This was it. The beginning. The pressure was building. The supervolcano was starting to pop. The internet did what the internet does. Rumors of an imminent full-scale eruption spread like wildfire. The 2022 magma data was dredged up as proof that scientists were covering up the truth. The Biscuit Basin explosion was not a small, isolated event. It was a precursor, a warning shot from the deep. The Yellowstone Volcano Observatory and the USGS were forced to respond, and to do so with overwhelming, data-driven clarity. Their conclusion was swift and absolute. The event at Biscuit Basin had zero connection to the deep magma chamber. This was not a magmatic eruption. It was a hydrothermal explosion. These are common, if frightening, events in Yellowstone. They are driven by the park's shallow plumbing system, not the deep volcanic engine. Groundwater seeps deep into the crust, where it is superheated by the surrounding hot rock. Sometimes, if the plumbing gets blocked by mineral deposits or the pressure changes suddenly, that superheated water can flash violently into steam. The expansion from water to steam is explosive, capable of throwing tons of rock and water into the air. It is a steam-driven event, not a magma-driven one. It's the geological equivalent of a pressure cooker exploding on a stove. The stove provides the heat, but the explosion is all about the water and steam in the pot. The USGS confirmed its findings using satellite data, ground deformation sensors, and gas emission readings. There were no signs of magma movement, no tectonic swarms, no surface uplift around the caldera. All the telltale signs of a pending magmatic event were completely absent. The Biscuit Basin explosion was a terrifying local phenomenon, but from a volcanic perspective, it was background noise. In a strange way, the event was a perfect case study for the real challenge at Yellowstone: the disconnect between public fear and geological reality. While the world worries about the 16-20% melt fraction in a magma chamber 5 miles down, the more immediate, tangible danger to a visitor on any given day is a sudden, unpredictable blast of boiling water from a shallow pocket of steam. Yellowstone is littered with the evidence of these events. Mary Bay, on the shore of Yellowstone Lake, is a massive crater over 1.5 miles wide. It was not formed by magma. It is the scar left behind by the largest known hydrothermal explosion in the world, an event that happened thousands of years ago. The 2024 explosion was a violent, viral, and ultimately irrelevant distraction. It proved that in Yellowstone, the scariest-looking events are often not the most significant. And the most significant truths are the ones buried deep in the data, not exploding on the surface. So, the new data says the magma is stable. The experts are less worried. The explosions on the surface are just steam. Does that mean we can finally relax about Yellowstone? The answer is complicated. First, we must dismantle the most persistent myth of all: the idea that Yellowstone is overdue for a supereruption. This concept is a fundamental misunderstanding of how geology works. Volcanoes do not operate on a human schedule. The statistic often cited is the average time between the 3 major caldera eruptions, roughly 725,000 years. Since the last one was about 631,000 years ago, simple subtraction leads people to believe we are approaching the due date. But volcanoes are not trains. There is no timetable. That average interval is just a mathematical artifact of a tiny data set. 3 eruptions over 2 million years. Statistically, it is almost meaningless. Furthermore, if you were to take it seriously, the math still doesn't support the overdue claim. It would suggest another 94,000 years to go. More importantly, geological systems do not just repeat themselves. The Yellowstone hotspot has been active for over 70,000 years since the last supereruption, but its activity has been in the form of much smaller, sluggish rhyolitic lava flows, like the one that formed the Pitchstone Plateau. The system may be winding down, its energy dissipating in these smaller events rather than building towards another cataclysm. The honest answer is that no one knows. Okay, last time, I promise. Probably, if you have learned something genuinely new, something that reshapes how you see this story, subscribing is the single best way to support more deep dives that cut through the noise. It is genuinely that important to us. Thank you. The greater, more immediate threat to the region has never been the volcano. It has always been the ground itself. On August 17th, 1959, a magnitude 7, 3 earthquakes struck near Hebgen Lake, just west of the park boundary. It was a purely tectonic event, unrelated to magma, but its devastation was real and immediate. The quake triggered a massive landslide that sent 80 million tons of rock crashing into a canyon, damming the Madison River and creating Earthquake Lake. 28 people were killed. That earthquake serves as a permanent reminder that the Yellowstone region is one of the most seismically active areas in the country. Tectonic faults, not magma, pose the most probable and potent hazard on a human timescale. This leads to the ultimate, uncomfortable conclusion. The biggest threat posed by the Yellowstone supervolcano in the 21st century may not be geological. It may be informational. The battle being fought by Dr. Poland and the staff at the Yellowstone Volcano Observatory is no longer just a scientific one. It is a battle against misinformation, against the cycle of fear and panic that erupts with every new study or hydrothermal burp. Their monthly video updates and constant public engagement are not just outreach. They are a critical part of the hazard mitigation plan. Because a population that cannot distinguish between a steam explosion and a magmatic precursor is a population that could panic disastrously in the event of a real, but smaller and manageable crisis. The paradox of the new science is that with greater knowledge comes a greater appreciation for complexity. We have a better camera now. We can see the sleeping giant with stunning clarity, but it is still a giant, sleeping in a room we can never fully enter, governed by forces we can only measure from a distance. The 2022 study did not give us certainty, it gave us better uncertainty. The journey began with a headline, a story of a magma chamber expanding, a threat growing beneath our feet. It ends here. With a more difficult, nuanced truth. It was not the magma that expanded, it was our knowledge. The audacious science of listening to the planet's hum did not reveal a new danger. It revealed, with unprecedented clarity, how stable the current system truly is. The story of Yellowstone today is not one of impending geological doom. It is a story of scientific triumph, a quiet, persistent battle against a rising tide of misinformation, and of our species slowly learning to coexist with one of the most powerful forces on Earth. The third straw in Las Vegas was built to reach water no drought could touch. The science at Yellowstone was deployed to see a truth no camera could capture. Both were multi-million-dollar gambles to gain certainty in an uncertain world. The science gave us clarity. The data gave us a measure of comfort. But the hotspot, burning deep beneath the surface for millions of years, remains completely indifferent to our measurements, our models, and our fears. The clock is still running, not on a schedule we can predict, but on a